All right, everyone. We got chapter 2 here. Chapter 2 is modeling a business. The first section of chapter 2 is interpreting scatterplots. You have seen scatterplots in the past, but we're just going to revisit them with more business applications. So I'm just going to read you this little blurb. Data is probably the single most important thing to a business. Good data can show trends that lead to major business decisions. What makes the success of a business hard in the first few years is lack of good data yet. If you guys ever watch Shark Tank, they always say, like, in the beginning, they test their market, they test their products to see what people in the public say about them because they want data on their products. Businesses use data in the form of scatterplots. Scatterplots may show a general pattern or trend within data. The trend may show correlation between variables, so like sales, time, all those types of things. And there are two types of correlation. Before I get into it, most companies, they obviously do this on the computer. Not Desmos like we use, but they have their own programs, I'm sure, that they chart the data in. So we're just going to do it by hand for now. So the first thing we have here is positive correlation. So positive correlation, I'm going to try to write neat, when the value of one variable goes up, as the value of the other variable goes. So what this means, basically, I'm going to draw a little thing right here. Let's say you have time and sales. So a positive correlation would be, as time goes on, sales go up. So as one variable goes up, the other one goes up. And a negative correlation is when the value of one variable goes down. Goes down as the value of the other goes up. So an example of this would be, we can still use sales and time, but as time goes on, sales go down. That would be a negative correlation. So you could pause it, take those notes. We're going to start the first example. All right, example 1. Rachel runs a concession stand at the park while she sells water bottles. She keeps a list of each day's high temperature and the number of water bottles she sells each day. Rachel is looking for trends that relate to the high daily temperature and the number of water bottles she sells each day. She thinks these two variables might be related and wants to investigate possible trends using a scatterplot. Below her ordered pair. So the data points are listed as x, y. So two variables. So the x variable is going to be the temperature, and the y is going to be water bottle sales. Now remember, x is your independent variable. So x, I'm just going to write indy. Here, your independent variable. Y is dependent. So the reason I put temperature as the independent is because the water bottle sales depend on the temperature. Whatever the temperature is, the water bottle sales follow accordingly. It's not the other way around. The temperature doesn't change because water bottle sales went up. So they give you all these points, and I'm going to show you what they mean. So 65 means at 65 degrees. So this is temp. She sold 102 bottles. So that's what that means. So we're going to make a little scatter plot here. So we're going to draw this. You always want to label everything nice. This is going to be water bottle sales. Water bottle sales. The bottom is going to be temperature. And now we're just making a sketch. So I'm going to start this at 100 because the bottle sales is the lowest is 100. So what I do here is I put a little kind of squiggly, which kind of says that we're skipping to get to 100. And then once we're at 100, we're just going to go up by 20. So there's 120, 140, 160, 180, 200, 220, 240, 260. And it doesn't have to be exactly like mine, but again, it's just a sketch. I'm going to do the same thing here. I'm going to make a little squiggly. And we're going to skip to, I guess we'll go by 10 and we'll start at 60. So 60, 70, 80, 90, 100, 110, 120. Now you're going to plot. So 65, 102, again, you're estimating. So that first one's going to be like there, over about 65, up about 102. 71, 133, so 71, 133, looks like it's about there. Again, it's just an estimate. I'm going to pause it and I'm going to fill them all out so you guys can do that, but you see what I'm doing. Ooh, I'm not on the page. So you can see what I'm doing, but I'm just going to pause it and fill them all out. So 79, 144, 79, 144 is like there. All right, now I'm going to pause it and then you guys can fill them out. All right, so there's my scatter plot. So if you look at it, it looks to me like there's a positive correlation. And why is that? Because as the temperature goes up, really the water bottle sales go up. So as temperature increases, water bottle sales increase. So just a little recap again with this one. You're looking at the data. You're making like a trend, like a prediction of the trend you see. We see that as the temperature goes up, water bottle sales go up. I know my sketch is kind of rough, but again, you're just sketching. Just make sure you know your variables. Remember, Y is dependent, X is independent. This bottom question says, if the temperature were to reach 68 degrees tomorrow, about how many bottles would you predict it sells? So 68 would be like here, almost at 70. Go up, I'd say it'd be like right in between 120 and 100. So that's about 110. So it's an estimate. It's an estimate. You're looking at the data. So I'm looking here. 65 is 102. 71 is 133. So about 110 it looks like in the picture. You know, a couple off would be fun. But there's your first example. All right, example 2. Sometimes trends are obvious, and you might not need a graph to tell you what they are or to tell you what would happen. So, for example, a local coffee shop sells hot chocolate. The manager keeps track of the temperature outside for the entire year in the hot chocolate sales. Do you think the scatter plot would show a positive or a negative? So, what do you think? So, this is actually a negative correlation. And the reason why is because hot chocolate sales will increase as the temperature goes down. So you might have thought it would be positive, like, oh, you know, the colder it gets, the more hot chocolate you're going to sell. But actually, the temperature is going down. The variable is going down. So you kind of have to be aware. You kind of have to be aware that one of the variables could go down. So that's why it's negative. Example 3, determine if it depicts a positive or a negative. What do we think here? What do we think? I'll pause it and let you guys kind of decide. All right, so hopefully you guys said negative, and there's an example, right? As temperature goes down, sales go up, could be negative, whatever you want. All right, So that one is negative. So example 4. Sometimes a trend is seen, but common sense may tell us that there's no correlation. An elementary school principal compiled the following data about 10 students at an elementary school. The first number represents a student's height. The second represents the reading level. Create a scatter plot. Do you think the person's height causes a higher reading level? So we can kind of predict that it's not gonna really affect height and reading level, right? You don't read better or worse because you're tall or short. So again, just kind of talking about this, it's saying that the height and the reading level have nothing to do with each other. Now, as time goes on, you ideally get taller and your reading level should improve, right? The taller you get, the older you get, the more you read, your reading level should go up. But just because the variables are related does not mean that they are associated. So this is the difference between correlation versus causation. So are the variables correlated? I mean, if they're correlated, they're associated in some way, but the student's height does not cause the reading levels to be a certain value. So if you were to really draw this scatter plot, let's just make a little plot here. We'll say, what do we got here? Let's say height on the side. I'll show you what it would look like. So reading level, we'll do 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Height, we'll go by 5, starting at, what's the lowest? 43. So we'll say 40, 45, 50, 55, 60. So 5.8, 48, over here. Right there, 63, 9.2. Over there, I'm just doing this kind of rough, 49, 5.5 there. I'm going to pause it and skip so it's all done. So there's a rough estimate of the scatter plot. Again, just to reiterate, a person's height does not cause a higher reading level. Most likely, both the height and the reading level for the elementary school students increase as they get older. Keep in mind that if the two variables are correlated, they are associated in some way, but the student's height does not cause the reading level to be a certain value. So that is the difference between correlation and causation. Last one here, the scatter plot shows the relationship between the number of text messages made by each of the 10 juniors while studying for Mr. G's math test last week and their scores in the test. Describe the trends you see. You shouldn't really see any trend. This is going to be no correlation. The amount of text messages you send really doesn't affect your score on the test. So that would be no correlation. So now that this is done, you guys are going to take these notes. I'll post the keys. You're going to take the notes and you are going to complete a practice sheet and turn that into classroom.